Good afternoon, dear students. So, today we'll be doing preparation of salts. Preparation of salts. Basically, there are two types of salts: soluble salts and insoluble salts. So, today, initially we'll be doing the soluble salts. So, how to make soluble salts? Generally, we know salts are formed when acid reacts with base, and it gives salt. Yes. Now let's see what are the different ways of preparing salts. So first of all, we'll go for soluble salts. Okay. Now, number one, direct combination, and this direct combination is also called synthesis. Why? Because we'll be heating two elements to make salt. So this is direct combination. Now metal plus non-metal gives salt. Any metal, zinc or sodium, anything. Say for example, take sodium plus non-metal, let's take chlorine. And why I'm writing Cl2? Because it is diatomic. And why I'm writing sodium as Na? Because it is monoatomic. So Na plus Cl2, it gives NaCl. It gives NaCl because valency of sodium is 1 and valency of chlorine is also 1. Now let's balance it. Here it is 2, so make this also 2. So this way we can prepare salt, soluble salt. That means if you dissolve this in water, it will completely dissolve. Sodium chloride is soluble in water. We have seen at home also. So soluble salt. So another example. For example, iron plus chlorine. Iron is a metal, chlorine is non-metal. So if this is reacting, then one is Na plus Cl2 gives NaCl. Other we can write other example, Fe plus iron is a metal, then here is chlorine, then it gives FeCl3, iron 3 chloride. What it gives? Iron 3 chloride or ferric chloride. So this is not balanced. Let's balance this. So 2 3s are 6, 2 3. So this way, by the process of direct combination on heating two elements, we get soluble salts. Another is simple displacement. Action of dilute acids on active metals. Now what do you mean by active metals? Metals which are lying above hydrogen in metal reactivity series are active metals. Metals lying above hydrogen in metal reactivity series are active metals. Active metals can displace hydrogen from acids. Active metals can displace hydrogen from dilute acids to form salt. So simple displacement. For example, active metal, any active metal, then hydrogen. Say for example, zinc plus acid, dilute acid, let's take sulfuric acid. Then what will you get in? This hydrogen of the acid, H2, this hydrogen, two hydrogen atoms of the acid will be displaced by zinc. So what is left here then? This is gone. What is left? SO4. So SO4. And what has displaced this hydrogen? Zinc. So zinc will come here. Zinc, Z and SO4. So this forms salt plus hydrogen gas H2. This H2 will be released as hydrogen gas, and this salt is also soluble salt. This is also soluble salt. And can you tell me whether this is acid salt, basic salt, normal salt? Yes, I don't see hydrogen here, so it is not acid salt. I don't see OH here, so it is not basic salt. So there is no hydrogen and no OH, so this is normal salt. So this is normal salt. Normal salt. Okay. The same way we can do another also. Say for example, Fe. Iron is also more reactive than hydrogen. So Fe plus HCl. Fe plus HCl gives FeCl2 plus hydrogen gas will be released. So active metal plus acid gives salt plus hydrogen gas. Now here this hydrogen is displaced by iron. So if you remove this hydrogen, you will get Cl only. And since valency of iron is 2 and valency of chlorine is 1, crisscross, you will get FeCl2 plus hydrogen gas. Okay. Now if I write Cu plus HCl dilute, then do I get cuprous chloride or copper chloride? Do I get? No, because copper is less reactive than hydrogen, and copper cannot displace hydrogen from dilute hydrochloric acid because this is less reactive, so it cannot displace hydrogen. So there is no reaction. Mind you, only active metal, that means more reactive than hydrogen, can only displace hydrogen from dilute acids. Okay. Now another way is decomposition. So by decomposition there are many ways. Decomposition of carbonates and hydrogen carbonates by acids. Decomposition of carbonates and hydrogen carbonates or bicarbonates by acids. So acid will be decomposing these salts. Carbonates or bicarbonate plus acid gives salt plus water. So for example any carbonate, NaHCO3, sodium bicarbonate I am taking, sodium bicarbonate plus acid, any acid you can take, say for example HCl I am taking, hydrochloric acid. Then what will happen here? Then it will be NaNCl. That means Na will be displacing chlorine. So I will get NaCl salt plus water plus carbon dioxide gas will be released. NaHCO3 plus HCl gives NaCl plus water plus carbon dioxide. So most important is all these reactions you may not understand, you may not learn, but this general reaction, carbonate bicarbonate plus acid gives salt plus water, active metal plus acid gives salt plus hydrogen, metal plus non-metal gives salt, all these things you can learn. So here if I take Na2CO3 plus, say for example H2SO4, then what I will get? I'll be getting Na2SO4 plus, what is left? Water. Na2SO4 plus water plus carbon dioxide. So in this way, carbonates and bicarbonates react with dilute acid to give soluble salt plus water. All we are doing soluble salt here. All soluble salts only. Okay, so decomposition of carbonates, hydrogen carbonates by acids done. Now decomposition of sulfides or hydrogen sulfides. Sulfides means SO3 2 minus. Hydrogen sulfides means HSO3 minus. This is hydrogen sulfide and this is sulfide. So all the sulfides and hydrogen sulfides can be decomposed by acids. Sulfide, hydrogen sulfide plus acid gives salt plus water plus sulfur dioxide gas. Now let's take one sulfide or hydrogen sulfide. So let's take sodium sulfide, Na2SO3, sodium sulfide plus acid HCl. Then what I will get? I'll get this hydrogen will be displaced by Na. So what is left? Cl only is left, Cl. And what has replaced this hydrogen? So it is NaCl. So I'll be getting NaCl plus water plus sulfur dioxide. So in this way, sulfides or bisulfides, you can take bisulfides also, NaH, SO3 also you can take, plus HCl gives the same result, NaCl plus H2O plus SO2. So sulfite or hydrogen sulfide when reacts with dilute acid gives soluble salt plus water plus sulfur dioxide. Similarly, decomposition of sulfides by acids. Sulfides by acids. So here, any sulfide you can take, say for example, zinc sulfide. Zinc sulfide plus acid, say HCl. Then this zinc is displacing this hydrogen. So this hydrogen is not there. So what is left? Cl is left. Then zinc has replaced this hydrogen. So here will be zinc. But the valency of zinc is 2. So ZnCl2 plus H2S. Plus H2S. This way we can prepare this one, salt, decomposition of sulfides by acid. So sulfides plus acid gives salt plus hydrogen sulfide. So zinc sulfide plus hydrochloric acid gives zinc chloride plus hydrogen sulfide. Similarly, neutralization. So what is neutralization? When acid reacts with base and there is complete replacement of H plus of acid and OH minus of base, then there is a neutralization reaction. So neutralization. So for neutralization we need acid plus base. But if the base taken is soluble or alkali, then we will get soluble salt plus water, and the process is called titration. What is this? Titration. So what is titration? Titration is neutralization of acid with soluble base. What is titration? Titration is neutralization of acid with soluble base. Okay. So acid, any acid you can take, say for example HNO3 plus soluble base NaOH gives NaNO3 plus water. And this is, the process is titration. Okay. Now, soluble salts. This way we can prepare soluble salts. Number 1, direct combination, metal plus non-metal gives salt. Number 2, simple displacement, only highly reactive metal. That means those metals which are reactive, then hydrogen can displace hydrogen from acid to form soluble salt plus hydrogen gas. Then decomposition. In decomposition, there are decomposition of carbonates and hydrogen carbonates by acids. Now, number 2 is decomposition of sulfides and hydrogen sulfides by acids. Number 3, decomposition of sulfides by acids. And finally, neutralization. If this neutralization is the reaction with acid with soluble base, then it is titration. Now, we'll be seeing for insoluble salts. Now. Okay, now we will be preparing insoluble salts. Those salts which do not dissolve in water. Salts which are insoluble in water are insoluble salts. So insoluble salts can be prepared in 3 ways. Number 1 is direct combination. And this direct combination is also called synthesis. That means by heating two elements. Here also metal plus non-metal. Metal plus non-metal gives salt. And what the salt? Insoluble. So make sure that here you will not be using metal like sodium, potassium, and sodium, potassium. Don't use sodium, potassium like that, because their salts are not insoluble salt. So if you take metal like iron and non-metal like sulfur, then you will get iron sulfide. If you heat iron with sulfur, you will get iron sulfide, and this iron sulfide is insoluble salt. It will not be soluble in water. Similarly, if you take zinc plus sulfur, you will get zinc sulfide. But if you take Na plus Cl, then you will get NaCl, which is soluble. So for this, at least make sure that you take sulfur here and here this kind of metals, heavy metals, iron, zinc. Then only you will get insoluble salt. So one way of preparing insoluble salt is by direct combination, that is synthesis, by heating two elements. Okay, number two is this one, acidic oxide plus basic oxide. Acidic oxide plus basic oxide gives salt, that is insoluble salt. So acidic oxide plus basic oxides gives insoluble salt. Now take acidic oxide. So acidic oxide, for example, I am taking sulfur dioxide, plus basic oxide I will be taking calcium oxide. Now if I heat this, then I will get calcium sulfite. Sulfur dioxide plus calcium oxide on heating gives calcium sulfite, which is insoluble salt. Similarly, carbon dioxide, acidic oxide, plus calcium oxide, basic oxide, when these two are heated, we will get calcium carbonate, which is another insoluble salt. So this is second way of preparing insoluble salt. Now the third way, by the precipitation reaction. Or this precipitation reaction is also termed as double decomposition reaction. So precipitation is the process by which insoluble salts are formed. They will be precipitated, that means they will be in the form of solid. They are insoluble. Now soluble salt plus acid or any soluble salt we can take here. For example, soluble salt, barium chloride is a soluble salt, silver nitrate, then lead nitrate, copper sulfate, all these are soluble salt. Acid or soluble salt, acid H2SO4, HCl, and this is soluble salt plus H2, okay, H2S. Now let's see, barium chloride when reacts with sulfuric acid, then this H2 will be replaced by barium. Then what will get? From here we will get SO4. Then H2 is replaced by barium as a metallic ion, so it becomes BaSO4. So barium sulfate is insoluble in water, so it is precipitate. Plus what is left now? H2 is left and Cl is left, so it becomes HCl. Similarly, silver nitrate plus hydrochloric acid. So this hydrogen will be replaced by silver. Then what we will get? If hydrogen is replaced, then what is left here? Cl is only left. Then this hydrogen is replaced by silver, so it will be AgCl plus what is there then? NO3 and H, so it forms HNO3. Balancing, yeah, it is balanced. Then lead nitrate plus sodium carbonate. Now this sodium will be replacing lead. Sodium will be replacing lead because sodium is more active than lead. Now what we will get? If sodium is replaced by lead, then we get here we get CO3, and this Na has gone here, that means Na has replaced lead, so here will come lead, PbCO3. Lead carbonate is also insoluble, and what is there? Na and NO3, so we will be getting NaNO3 which is a soluble salt, acid or any salt. So we are getting salt here. Now Na2, so 2. Okay. Copper sulfate plus hydrogen sulfide. Copper sulfate plus hydrogen sulfide. This copper will be displacing this hydrogen from hydrogen sulfide. So what is left here? S only. And what has displaced this? What has replaced this hydrogen? Copper. So it will be CuS plus Sn. This is H2 and SO4, so it becomes H2SO4, sulfuric acid. Okay, so this way, by the precipitation reaction, we can make insoluble salt. So 3 ways of making insoluble salts are: number 1, decomposition, combination, direct combination or synthesis. Metal plus non-metal gives salt. Insoluble salt, generally we will be taking sulfur as a non-metal, and in metal we will take heavy metals like zinc, iron and all. Now acidic oxide plus basic oxides also gives insoluble salt. Then this one, soluble salt plus acid or soluble salt gives insoluble salt plus acid or salt. Okay, now this is all about preparation. This is all about preparation of salts. Now from this chapter, whatever is there in your syllabus is all done. Now 3C is not there in your syllabus, so we will not be doing that one. That is this one also. 3.5.3 laboratory preparation of some salts will not do. Then exercise 3B, whatever we have done you do, and the objectives you just do in the book only. Then 3C, properties of salts, no need because it's not in syllabus. This is for reference only. So 3C you don't have to do, but miscellaneous questions based on ICSE examinations you have to do. Okay, so now before this preparation is done, now we will be seeing the solubility of salts. Solubility of salts, here we will be writing salts, and here exceptions. Number 1, all compounds of sodium, potassium and ammonium are soluble in water. For example, NaCl, then NaCO, Na2CO3, K2SO4, NH4Cl, all these are soluble in water, and there is no exception. That means all the compounds of sodium, potassium and ammonium are soluble in water. Even sodium hydroxide, potassium hydroxide, ammonium hydroxide, all these are soluble in water. So only, mind you, only sodium, potassium and ammonium salts or compounds are soluble in water. Without second thought, whenever you see this type of compounds of sodium, potassium and ammonium, you can say they are the soluble compounds and they are soluble salts. If they are salts, if they are compounds, if they are hydroxides or something, then you can say all compounds of sodium, potassium and ammonium are soluble in water. Okay. Now, number 2, all nitrates and nitrites are soluble in water. All nitrates and nitrites are soluble. Exception is not there. No exception. That means all the nitrates and nitrites are soluble. For example, lead nitrate, then sodium nitrite, potassium nitrate, all the nitrates and nitrites are soluble. Number 3, all sulfates are soluble. All sulfates are soluble, except, there is exception, except calcium sulfate, barium sulfate, lead sulfate. These are insoluble sulfates. These are insoluble sulfates, and rest all sulfates are soluble. For example, Na2SO4, MgSO4, then K2SO4, then ZnSO4. All these are soluble sulfates. All these are soluble in water, but these are insoluble in water. So these exceptions you have to know. These are okay, but if you know the exceptions, then rest are okay. So you should learn the exception. Here no exceptions. Here this is the exception. Now number 4. Number 4. All sulfates are soluble, we have done. Then all nitrates and nitrites, all chlorides. All chlorides are soluble. All chlorides are soluble. All chlorides are soluble. Exception is there, except lead chloride. Whenever you see lead chloride, then this is insoluble. Lead chloride, then silver chloride, then mercurous chloride. These are insoluble chlorides. These are insoluble chlorides. And soluble chlorides, sodium chloride is soluble, then magnesium chloride is also soluble, zinc chloride is also soluble, then copper chloride, calcium chloride is also soluble, but lead chloride, silver chloride and mercurous chloride are insoluble. They are not soluble in water. Then number 5, all carbonates, bicarbonates, sulfides, bisulfides, then sulfides, all carbonates. Carbonates means bicarbonates also, sulfides, bisulfides also, and sulfides are insoluble. Mind you here, all carbonates, sulfides and sulfides, bicarbonates, bisulfides are insoluble. But mind you one thing, the first point, what was the first point? All the compounds of sodium, potassium and ammonium are soluble. Means here also all the carbonates, bicarbonates, sulfides, bisulfides, then sulfides of except carbonates, sulfides of sodium, potassium and ammonium are soluble. So point number 1 will rule over this. Point 1 will rule over this. All the compounds of sodium, potassium and ammonium are soluble. Either it is carbonates, sulfides, sulfates, nitrates, all are soluble in water. Okay. Now, this is all about the solubility of salts. Hope you are done. Then I will give you some work to do. Objectives. Some work I will give you. So what you should learn? All the compounds of sodium, potassium and ammonium are soluble in water. Question. Homework, as I said, all the exercise from the textbook, those objectives you can do in the book only, and those which are lengthy one you can do in your copy. Okay, so column A and here column B. Number 1, sodium nitrate A, simple displacement. Simple displacement. Number 2, FeCl3. Number 3, PbCl2. Number 4, ZnSO4. Number 5, NaHSO4. These are some of the questions that generally comes from this portion. So B, neutralization. Then C, decomposition by acid. Number D, double decomposition or precipitation. Then E, direct synthesis, direct combination. Okay. Now, NaNO3, sodium nitrate. So, how do you think it's sodium nitrate formed? Ferric chloride or iron 3 chloride, lead chloride, zinc sulfate, and sodium hydrogen sulfate. So, how do you do this? Yes, some hints I will give this. How it was made? By direct combination. So, this is direct combination. And what about this lead chloride and this sodium nitrate? So how is sodium nitrate formed? Sodium nitrate must be this C. This is nitrate. That means it is from nitric acid. It is from nitric acid, and nitric acid is monobasic acid. So it must be with this one, neutralization. It must be with neutralization. That means titration, neutralization or titration, because this is nitric acid and this Na must have come from sodium hydroxide, which is soluble base. And when acid reacts with soluble base, this might have formed from this. So this is soluble base and this is acid. So when there is reaction with soluble base and acid, you will get titration, that is neutralization. So NaNO3 is neutralization. Then zinc sulfate must be from simple displacement, because zinc displaces hydrogen from sulfuric acid. Then NaHSO4 by the decomposition of acid, decomposition by acid. And lead chloride is insoluble salt. So insoluble salt must be, that means by precipitation or double decomposition. So this way, some more questions you can try, and then you will enjoy it. So this chapter is over. Whatever we are supposed to do from this chapter as per your syllabus is done. Hope you will study till then. Stay safe, healthy, and give some time for your chemistry work, all these exercises and all. Okay, thank you.